Hi and welcome. My name is Thomas, and in this episode we'll be looking at challenge number 9, retrieving the paper scraps from the server. So where we left off last time was Krampus updated the firmware on our badge, so now we should be able to roam around Elf University using the steam tunnels. So let's look at the challenge description first. Retrieving scraps of paper. So, gain access to the data on the student portal server and retrieve the paper scraps hosted there. What's the name of Santa's cutting-edge sleigh guidance system? First, we're going to be talking to Pepper Minstix in the dorm. So, let's use the steam tunnels, head over to the dorm. Quite a quicker way to travel than just hopping around the rooms. I'm not going to talk to Pepper because this is a re-recording as well. I already did that challenge and then unfortunately made a mistake, so here I am doing it again. So let's go straight to the Graylog server. There we go. I think it's LFU student is what Pepper gives us. And password as well. There we go. So for this challenge, we're going to be relying quite heavily on event IDs. And just as in a previous challenge, I'm going to be using, or I've used the Windows Security Log Events Encyclopedia as a bit of a guide to help me. Windows Audit Events as well as Sysmon Events are the ones that I've used most. So moving back to the actual Graylog server, we basically need to do some threat hunting, and we need to fill out this LFU Graylog Instant Response Report. This has a couple of questions for things that we need to find, and so let's kick things off with question number 1. Minty Candycane reported some weird activity on his computer after he clicked on a link in Firefox for a cookie recipe and downloaded a file. What is the full path plus file name of the first malicious file downloaded by Minty? So to find this, let's head over to all messages. Let's set our time frame to all messages as well, not restrict ourselves. And the first thing we're going to be looking for is processes that write files. And for that, we're going to be using event ID number 2, Sysmon event ID number 2. So we look for event ID number 2, and we say we want to look for anything that was written by Firefox and is not something that ends with temp at the end. That is just to get rid of some of the noise that we would otherwise be seeing in the results as well. These forward slashes just indicate regex expressions as we search. So let's enter. And what we see here is, let's actually use add target file name and add process image as well, and get rid of message. Process image is Firefox, so that is the process that's performing the activity, and the target file name, what is being written to disk, is cookierecipe.exe. So answer to question number 1 is going to be this path and that binary. There we go. Question number 2. I need to keep my mouse over this. Okay, question number 2. The malicious file downloaded and executed by Minty gave the attacker remote access to his machine. What was the IP and port the malicious file connected to first? So now we're looking at Sysmon event ID 3, which is network connections, and we want to know about network connections as they relate to that cookie recipe binary or process. So process image is going to be that path that we found earlier, and we're going to request or look for event IDs number 3. So search for that and look for destination IP and destination port. And here's our answer, 192.168.247.175, and destination port is going to be 4444, which is, I think, the default Meterpreter reverse shell port if you use Meterpreter in something like Metasploit, for example. So we're going to be copying over this IP address. Go back to question 2 here in our answer form. Add port 4444 and submit. Next, what was the first command executed by the attacker? So for that, what we want to do is want to look at process executions or process creation events, and especially the ones that have that cookie recipe as their parent. So event ID 1 is the one that we're looking for, Sysmon event ID 1, and the parent process name is going to have to be, or the parent process image needs to be that cookie recipe. So let's enter on that. Let's sort that by timestamp, the oldest ones first, and let's add the command line because that's what we're interested in. So after the cookie recipe, the first thing that gets executed here is going to be who am I, then some ls, etc., etc. Looks like some recon activity. So who am I seems to be the answer to this particular question. So let's answer that as well. Who am I? There we go. Next up, question 4. What is the one-word service name the attacker used to escalate privileges? Now we could actually modify our query and search for something else or add something to that search, but we could also just move down the list to see anything that's service related. And what you'll find is this particular entry right here, where you'll see SC, which is the Windows command to use to control a Windows service, being run, and then as the command line see start WebEx service, a software update 1 wmic, and then process call create, and then a process name or new process file, basically cookie recipe 2. So in this case, what's happening is they're using the web exec vulnerability in WebEx to basically escalate privileges. You'll basically use this exploit to move your privileges from whatever user account you're at that time. For example, system. So the answer to this particular question is going to be WebEx service. And at this point, our attacker has escalated their privileges and can pretty much do whatever they want at this point. So WebEx service. Question 5. What is the file path plus file name of the binary ran by the attacker to dump credentials? So dumping credentials obviously needs those escalated privileges. So we need to look for anything that spawned out of that second, what's most likely a reverse shell with escalated privileges or elevated privileges. So we're going to be using the same query as before, but we're going to be replacing cookie recipe with the new binary that was found on that machine. So cookie recipe 2, the one that's running with the elevated permissions. So let's execute that, and we should be able to see at some point some invoke web request entries, which download Mimi drive of Mimi drv.sys to disk. It also downloads, let's see, have I sorted by time? I have not sorted by time. That probably makes more sense. So it downloads Mimikatz trunk as cookie.zip. It also downloads mimikatz.exe as cookie.exe, downloads mimikatz.exe twice actually, it seems, and then mimilib as well, mimilove as cookielove. So there's a few things being downloaded that are Mimikatz related for credential dumping, and then further down we'll see that it actually does the dumping itself as well, once as Mimikatz and once as cookie. Now we can try either of these, but the correct answer is actually the second one, cookie.exe. So let's add that as an answer without a space. There we go. There we go. Next, the attacker pivoted to another workstation using credentials gained from Minty's computer. Which account name was used to pivot to that other machine? Okay, so now we're talking about a whole different log event, and we're basically talking about Windows events now. What we're going to be looking at is event ID 4624. So let me grab that real quick from the encyclopedia, because I'm going to need that a few times for the next couple of questions. There we go. An account was successfully logged onto. So log on event, that's what we need. And so what we're going to be looking for is anything that was initiated from our attacker machine and is not the destination of the workstation we're looking at right now, which is WKS1, and has that event ID. So search for that. There we go, and if we add the account name to that, we can see that it was actually using Alabaster as the name. So Alabaster, and adding that as well as the answer to question 6. There we go. 7. What time the attacker makes a remote desktop connection to another machine? Okay, so this is where you need to start looking at logon types for event ID 4624, because there's different logon types that tie to the way that the logon activity happens. So one is, for example, going to be remote interactive, which is number 10, and that relates to remote desktop. So in this case, that's going to be the item we're going to be looking for. So this query is going to be fairly simple. It's going to be that event ID 4624 and that particular logon type. There we go. And we need to add a few more things like destination host name and source host name. There we go. And then we can also add logon type. We already mentioned that. We know what that is. Okay, and the timestamp for this is 060428. There we go. We didn't really need all the other information, but for completeness sake, there it is. So let's add that timestamp as an answer to question 7. There we go. Submit. Perfect. Now question 8. The attacker navigates the file system of the third host using their remote desktop connection to the second host. What is the source host name, destination host name, and logon type of this connection? Okay, so we're talking about navigating the file system. So this is probably different than remote desktop logon. And so let's look at our additional logon types here. And more specifically, let's look at number 3, which is connection to a shared folder. Which is what we're interested in here. Now, looking for the same thing, but what I'll do in this case is I'll restrict the actual events to things that happened after the other activity that I've searched for thus far. So I'm going to use that timestamp from the previous question. I'm going to use that as a starting point, then look for those login events, and then anything that's related to those shared folders. So search for that. There we go. We have a few of those. The one that we're interested in obviously is the source host name WKS2, and that goes to WKS3, and that is logon type number 3. So that's the answer to question number 8. So let's copy and paste that from my notes. Number 8. There we go. And submit. Perfect. Question 9. What is the full path plus file name of the secret research document after being transferred from the third host to the second host? Okay, so for this, we're kind of moving back to the initial sysmon event that we started off with. Sysmon event number 2, which is file creation event. And we're going to be looking for event number 2, which has a source of WKS2, because it needs to be created on that host. Timestamp, again, as before, we're going to take everything that happened after that specific timestamp we found earlier, and we're not interested in anything that gets written to disk, which might be a temporary file. Let's filter those out just to keep the total number of results down. So let's run that. Let's get rid of some of the redundant fields. So destination host name, don't need that. Command line, get rid of that, etc, etc. So as you can see, there's another temp file here. Don't need to worry about those. New config, don't need to worry about those either. But this PDF file has a name, which is super secret LView research. I would assume that that is something that an attacker would want to exfiltrate, especially if it's just being written to disk on that machine, which we know it has been compromised. So let's paste that into the answer for question number 9. Do I need to have full path plus file name? Yes. There we go. And then question 10. What is the IPv4 address? As for in the logs, the secret research document was exfiltrated to. So first things first, we need to know everything or find everything related to that secret research document. So I'm just going to do a simple search. That searches for that particular string. There we go. And so that gives me a few things. Let's sort that by timestamp, and let's get the command line in there as well, because the command line is going to give me that valuable information. Namely, PowerShell was used to make a post request with that file. So it reads that file, read all bytes, it reads that file, that PDF document, and then it does a web request to pastebin, where it basically posts that information to pastebin. So we know that the attacker exfiltrated off to pastebin, but we still don't have the IP address. So now we use that information together with sysmon event ID 3, which is a network event. And we say, well, the destination host name needs to be pastebin.com. So we look for that, and then we need to add the destination IP. Destination host name might add as well. So destination host name pastebin.com, and the IP address that we're looking for is this one. So we add that as well. And hopefully that should Successfully fill out the full form. There we go. Incident fully detected. We're good to go. We can move on. Pepper talks about SQL injection as we mentioned, or as we talk with him about the student portal challenge. He also talks about tamper scripts potentially and blind SQL and SQL injection and SQL map. So now we have some information to move over to that particular challenge. Retrieve scraps of paper from the server. So let's open the student portal. There we go. So student portal, SQLi, SQL map, we'll need to find some forms or at least some form of input that we can exploit. So let's see what all the different categories are about. So this is a form here and we have a different form here. Okay, perfect. Now let's look at the actual source, see how what that form looks like. So the form basically, as it submits, it runs the submit application script or function, JavaScript function. That function runs elf sign, and elf sign basically does a request to the validator.php script, which is going to return a specific token. We can test that ourselves as well. Elf student portal, I guess, student portal, and then validator. This is just a random token that we get back. And that token is submitted together with the form to the server, and that will be validated on the server side. If it's deemed to be correct, then the form is going to be submitted successfully, and our data is going to end up in the database, or it's going to manipulate that database with whatever we submitted in the form. If the token does not match, our request is going to be dropped, and this is a kind of a protection against cross-site request forgery, which is what we're looking at here. So let's submit something in this form. Let's see, demo at, let me say chn demo at example.com, course of study, or whatever, doesn't matter, a number, or whatever. I'm gonna keep track of this, see if I can paste that somewhere so I can use it later on, and I accept the conditions. That's fine. Submit the application. Okay, so it's been approved, it's been received. If I check my application, I'll see that is pending. Okay, perfect. Now I'll move over to my Kali machine for SQLMap. One of the things that SQLMap has as a parameter is it has support for providing a link or a URL or a location where it can download tokens which need to be submitted together with the request. So there's a CSRF URL parameter and a CSRF token parameter. Now, the issue with the data that comes back from the validator script here is that validator.php, there's nothing in this response. Let me actually show you the page source. It's just a straight up token. If I look at, let's see if I can find this network. Let's reload this. Look at this. In the response headers, there's also no tokens in there either. That SQLMap can use to extract that token from, and it's expecting to see that, otherwise it'll fail. And so just to show you what that looks like, let's see if I can copy that over again. Then I need to grab my demo. Probably need to change this to the URL encoded. It's going to be %40 elf email, and then token, whatever, that's fine. I think that should be okay now. And now I'm going to add those two URLs, that two parameters. There we go. So CSRF URL, which points to that validator.php script, and then for CSRF token, I don't have anything I can specify. So let's just try an empty string. So let's see what that does. Okay, that fails. So let's see if I can just leave off the token altogether. Well, that fails again. Okay, so now I need to find a way to actually translate this response that we get from the student portal and turn it into something that does have what we need. And for that, what I did to solve this is I created a particular script. It's basically just a quick small Flask application, full Python Flask application. Its only purpose is to respond to a request by first grabbing a token from the student portal validator script, and then putting that token in as many possible locations that I can, which is going to be as token colon the token in the body itself, as a value in an input field in the same body, and in the headers as well. Might as well just spam it everywhere, make sure that SQLMap can find it if we do our requests. So now I need to run that and make sure it's listening, obviously. So it's called token.proxy. So that is running. We can actually test that out. We can say, and that'll grab a response for us. It has added token. If we look at element here, see there's a form in there which has an input field, and that input field has a name called token, and it has the value in there as well. And if we look at the network connections, let's reload this. There we go. It should have a response, header response as well, which has token in there as well. So that token is in there everywhere, right? If SQLMap doesn't find it now, I think we have larger issues that we need to address. Anyway, so what we can do now is we can run that command again, but instead of specifying the validator.php script, I can now specify my own application. So let's paste that in. Port 5000, that's fine. Let's make sure we see that. And then specify as a CSRF token the token name, which is going to be token. That's what I called that field. So let's go and see what SQLMap makes of this. There we go. So now we see that as SQLMap is running, it's basically, and let me answer yes to this question, because since we know it's detected it's MySQL, we don't need to check any other databases anymore. So let's grab that. Nah, we can do with the level ones and the risk ones. There we go. So as SQLMap is actually running doing its thing, you can see that my Flask application is responding here to the requests, right? So that's SQLMap asking my application for a valid token and using that token to actually submit the SQL injection requests or SQL injection attacks to the student portal. SQLMap has different ways on how it can perform attacks. The higher the level, as far as I'm aware, but please correct me in the comments if I'm wrong, the more noisy or the more detectable the attack might be. So I'm sticking with 1.1. Most likely it'll find a few things, so we should be good with just doing those. The nice thing though with SQLMap is it helps you do some of the heavy lifting with the SQL injection attacks. For example, it's an awesome tool if you're looking at blind SQL injection, timed SQL injection. The way that it would work in that case would be it sends a request, it looks at how long it takes to respond, it changes that request slightly, looks at how long it takes to respond, and based on that response time it knows that the request was either successful or it failed, and based on that it can do certain things as well. So waiting on a few things. Get parameter elfmail is vulnerable. Do you want to keep testing for others? Well, no, I only need one actually, so that's more than enough. So I have two vulnerabilities, two ways to exploit. One is Boolean based blind and the other is going to be error based. So now that I know the database is MySQL and I know that we have successful ways to exploit, I can now start enumerating information from the databases. To know what I need to enumerate, I obviously need to know what databases I have. So first things first, let me specify the database as MySQL. There we go. And then let's get a overview of all the databases first. So let's see what we have. Okay, so it's testing if it's MySQL as I'm specifying, which it is. It's confirming, that's fine. And hopefully it should now be able to use the exploits that it detected earlier to actually go and grab that information. So I have two databases, LView and Information Schema. Information Schema we can ignore because that's the default MySQL database. LView is going to be the one that we need. So the next step would be, well, now that we know the database, which is LView, can you please give me the tables in that database? So let's run that again. Oops, I have, and oh yeah, obviously I only need one of them. There we go. And off to the races, testing for MySQL again. And we have three entries in that table, in that database. We have the applications table, the Krampus table, and the students table. So just for time's sake, I'm gonna go straight for the one that we need, which is Krampus. And I can now use that information by specifying tag D. No, I already have that. I need tag T, sorry, for Krampus. No, now I'm specifying the table. And now I want to say, well, dump everything that's in that table. And now it's going to do the exact same thing again. There we go. And it's finding the fields, ID, which is an integer, and path, which is a text string. And it's going to start dumping all the records in that table. There's going to be 6 of them, and all of them look like image files. Perfect. So now we have our dump database information, and just to quickly confirm that what we have here is what we're looking for, let's copy that and let's look at student portal, not the validator, but that image file. And there we go. That is one piece of that scrap of paper that we're looking for. So let's do just one more. Oh, obviously not the way to do this. There we go. And that's another scrap of paper. So you can download all of the 6 of these, and then you can start recombine them using whatever image editor you prefer. And so this ultimately gives you the following, which is a letter. Unfortunately, we're still missing a quite critical piece, which kind of identifies who the attacker is. So that's kind of a bummer. But we do have the answer to the question, namely, finally I figured out how to destroy Christmas. Santa has a brand new cutting-edge slate guidance technology called the Super Sledomatic. So I think this is what we need, right? Super Sledomatic seems to be the name of that guidance system that we were asked about. So let's go back to our badge and let's add that into, or submit that as the answer. And yes, we've got it. Awesome. So let's see, anything else that we need to do before we end this? I don't think there's anyone we need to talk to right now. Krampus, I don't think. Nope, we should be good to go. So 3 more challenges left, 3 more associated hints left. We're almost at the end. But we're getting significantly more difficult. The next one is going to be a 5 difficulty rating, then another 5 difficulty rating, and then we'll end with a 4. So we're gonna have to, things are gonna get a little bit more complicated in the next couple of episodes. As always, thank you very much for watching. I hope you've enjoyed this video, and I'll see you in the next one. Thanks very much. Goodbye.